Here is the calculation for the margin of error. And there are three components. There's three components. You'll notice this is the standard deviation. That's sigma from your data set. This is the count, the number of items that are in your sample. And this is that z-score that we talked about. And remember, this z-score, this is a z-score. This is based on your confidence level. So if you have a 95% confidence level, your z-score is 1.96. That's the number that you plug in for z. So the confidence level indicates your z-score. And then that z-score gets used along with the standard deviation and the count in order to calculate the margin of error. Once you have that margin of error, you add it to the mean, you subtract it from the mean, and there's your interval. This is how you do large sample sizes. Large sample sizes being values greater than 30. And what about smaller sample sizes? And we talked about this idea of a sample size. Here is a normal distribution, and here is the value for n. Let me kick this up to 50. There we go. Okay, and so if I change the sample size, let me get rid of this area. If I change the sample size from 30 to 50, you barely notice any change in the graph. So I'm moving the sample size from 30 to 50, and the graph is nearly identical. It's a normal distribution, everything's fine. But the minute I dip below 30, you can see that the graph really starts to change shape, and that impacts the area in the calculations. So anytime you have a sample less than 30, we can't use the z-score. The z-score breaks under 30 because the shape of this graph breaks under 30. So when we have a sample less than 30, we have to use a different score. The z-score breaks, and we have to use something called the t-score, or this is called the student's t distribution. Instead of using a z-score, you will use something called a t-score. You still multiply by the standard deviation. You still divide by the square root of the number of items, and that is your margin of error. And so once you calculate this margin of error using the student t distribution, you add and subtract it to the mean. Now this t distribution, and we talked about this. Remember way back up here when we talked about the z-score. What determines your z-score? What determines the value of the z-score? Well, it was the confidence level. So if you had a 95% confidence level, that meant your z-score was 1.96, and then that led to the number being put in. So it's the confidence level that determines the z-score. What determines the t-score? In other words, this score right here, what determines that value? Well, there are two things. Item number one is your confidence level. Again, that would be your 95% confidence. The second thing is called degrees of freedom. Degrees of freedom. There is no political undertone to this. The degrees of freedom are explained down here. And here's sort of a way of thinking about the degrees of freedom. Basically, if you have 10 items, the degrees of freedom are equal to 9. It's one less than the number of items that you have. And here's how a way of thinking about that. Imagine there are 5 people and 5 chairs. The first person has the freedom to choose what chair they want to sit in. They get to pick from 5. And the second person gets to pick, and the third person gets to pick, and the fourth person gets to pick. But the fifth person, when there's one person and only one chair left, they have no degree of freedom to choose what chair they want to sit in. And so if you have 5 people, the degrees of freedom are 5 minus 1, which is 4. 4 people, 4 of the 5 have the freedom to choose where they want to sit in what chair, but the last person does not have the degree of freedom to choose. And so that is the second thing that goes into the value of t, this t-score. So you got to first identify your confidence level and then your degrees of freedom. Once you have that, you can look it up in a table. This is what your grandparents would do. They would look it up in a table and get the value for t, or we're going to use technology. We're going to use a Google Sheet, and we're going to plug in the confidence level and the degrees of freedom, and it will give us the t-score. We then take that t-score, multiply it by the standard deviation, divide by the square root of the count, and that is our margin of error. We then add and subtract that from the mean, and that's our interval. So there are a lot of steps in this process, okay? As you're working on these problems, here's the difference. So again, if your n value is greater than 30, you want to throw in a z-score. If your n value is less than 30, you want to use the t-score, or greater than 30 as well. So the t-score works universally. It works for everything. And then once you calculate this margin of error, you're going to take that margin of error, regardless of which one you use, and you're going to subtract it from the mean to get the lower bound. You're going to add it to the mean to get the upper bound. You can go to this website and collect the reported IQ of celebrities. And so we just randomly went in and grabbed 20 celebrities and recorded their IQs. So here they are. And what do we need from this data set? We need the mean. We need the standard deviation, we need the count, and we also need, let's say, our confidence level. Now, we don't get that directly from the data set. That's something that's going to be provided for us. So we need to find the mean, the standard deviation, the count, and the confidence level. And so what's going to happen? Well, if we were to graph this, this would be our mean, right? We're going to use that as the mean. And then we are going to take these three characters and we are going to find the margin of error, right? We're going to take our t-score, which comes from the confidence level. We're going to multiply that by sigma divided by the square root of n. So whatever these values are, that will give us our margin of error. We're then going to take that margin of error, we're going to add it to the mean to get our upper boundary, and then we're going to subtract it from the mean to get our lower boundary. That is the plan, okay? So we take a look at our data and we find that our mean is this, our standard deviation is this, our degrees of freedom is 1 minus the count, or the count minus 1, pardon me, the count minus 1. So 20 minus 1 is 19, and we know that our confidence level is 98. So we take the degrees of freedom and our confidence level, and we find the value for T. We're going to do this using Google Sheets and a formula called TINV. We'll show you that in just a little bit, okay? So this is our t-score, otherwise known as the modded z-score, okay? We take that t-score, we plug it in here. This is our standard deviation. This is the count, and we get a margin of error of 16.6. We take that 16.6, we subtract it from our mean to get our lower bound, and we add it to our mean to get our upper bound. And that is our interval. So now we could say that we are 98% confident that the IQ for all celebrities is between 128 and 162. That's our confidence interval. Now, again, in the real world, leave out the 98% and would just say the IQ for famous celebrities is between 128.8 and 162. Just my opinion. I think the world would be a lot better place if when people made numerical statements, they would include their confidence in that statement. Like if the weatherman said, tomorrow's high is going to be between 50 and 60 degrees, and I'm 95% confident. Imagine if politicians, when they made statements, had to include confidence levels with their statements. How confident are you in that statement? Well, mathematically, I have to say that I'm 30% confident, but I'm 100% confident in my heart. Wouldn't it be just better, like, to know how confident people really are in the statements that they make? That's kind of the cool thing about statistics, is that we can actually calculate in it. We can actually, without a doubt, say we are 98% confident. And here's the mathematics behind it. Here we have 28 objects. This is our sample size, 28. We have a mean of 48. We have a standard deviation of 6, and we want to find the margin of error at an 80% confidence level. So notice they're only asking for the margin of error, not the interval. So our sample size is 28. That goes in right there. Once we know the sample size, we immediately know the degrees of freedom. The mean is 48. The standard deviation is 6. And our confidence level is 80%, so 0.80. So 80% confidence is 0.80. So what the Google Sheet does is it calculates the degrees of freedom by subtracting 1 from the sample size, okay? It calculates the t-score, modified z-score. And look how it does it. This is the formula, TINV. So it takes the probability. Now, this is the probability under the tails, not in between. So unfortunately, we got to find, if it's an 80% confidence, we're looking for something called the significance level. And this is just how it's programmed. And you'll see why when we get into module 8. So in module 8, instead of talking about confidence levels, we talk about the complement of the confidence level, which is the significance level. And that's what goes into these calculations. So you take the 0.8, you subtract it from 1, and you get a 20% significance level, and the degrees of freedom go here. That is your t value, your modified z-score. You then take that t value, this is the t value, you multiply it by the standard deviation, which is the purple box, the 6, and then you divide by the square root of the number of items in your sample, 28. And that gives you your margin of error. So there's our margin of error. That's it right there. Boop. We'll round that up to 2 decimals and we should be good. Okay. Now, what else the spreadsheet does is it then takes that margin of error, it subtracts it from the mean to get the lower bound, and it adds it to the mean to get the upper bound. So that's kind of nice. It automatically gives you your interval. So let's go to question number 7. So question number 7 says, if n is 32, x bar is this, standard deviation is that, construct an 80% confidence level. Okay, so let me clear out all my data here. The sample size is 32 items in my sample. The mean is 35. My standard deviation is 6. And my confidence level is 0.80. Here's my degrees of freedom. Here's the t value, the modified z-score. Here's the calculation for the margin of error. Here is my lower boundary. Boop, boop. And here's my upper boundary. Copy, paste. And there we go. So for this data set of 32 items with a mean of 35 and a standard deviation of 6, we could say, remember, this is a sample. This is a sample of trees from the Manistee National Forest. And we are saying that we are 80% confident that the height of all the trees for the whole population is in between 33.6 and 36.4. From this sample, we are 80% confident that the average for the entire population is within this interval based on the information from our sample. So that's what we're doing. We're making projections about an entire population from a sample with a certain confidence level. Again, don't do these problems till you get them right. Do them till you can't get them wrong. So I'd click in here and I do a similar question. So in this case, my n value is 22. My average is 43. The standard deviation is 16. And my confidence level is 0.99. So here's my degrees of freedom. Here's my t score, my modified z-score. Here's my margin of error. Wow, big margin of error. And here is my lower boundary. And here is my upper boundary. And you may say, why is this so wide? Why is the margin of error so big? Well, look at your confidence level. Your confidence level is 99%. Watch what happens when I drop that confidence level from 99% to 80%. Look what happened to the interval. Look what happened to the margin of error. It gets smaller. When your confidence goes down, your margin of error goes down, and your interval gets smaller.